background information about the microscope. So the basic information or basic concept which we are using in the atomic force microscope. So here is a force distance relationship, LJ potential is very important. Then advantages and disadvantages. Then the technological importance, all covered in 1 hour. Experimental setup, schematic view, and topography. Topography important. So here, just I will put it in this slide in order to understand why the techniques are very important. Because normally the microscope, why we use to see an object which is very difficult to see through our naked eye. So it means our naked eye has a resolution or resolving power is very low. That is why we are looking an object in depth there, how the molecule or clusters are assembled. So then there is a paradox. So if you look at any object, so meter like human height, centimeter scale like our hand, hair dimension, hair 100 micrometer. Human hair is between 60 and 80 micrometer depending upon the age bracket. But it is less than 100 micrometer. Then cells, blood cell, E. coli, HIV. But here these are bacteria. Bacteria, red cell, E. coli, these are bacteria. So it is less than greater than 100 nanometer. But below 100 nanometer, we called it is a nanometer, nanoscale, or nano objects. So there HIV, hemoglobin, glucose, and other viruses. So the viruses are coming under this category, nano scale category. Bacteria are coming into the micro scale category. Then bigger objects. So these are the way. The very minimum object, hydrogen, is a fundamentally very small. So one atom configuration. So it is roughly 1 Armstrong. That is why I told you, 10 hydrogen atoms pile up, you will see 1 nanometer. Then, so these are also basically the same. The bottom one, you look, I already told, viruses are very small. Viruses are in the nanoscale, whereas bacteria are in the microscale. Why the virus, what is the maximum diameter? So the size of the viruses, for example, the coronavirus, which is people suffered a lot, is 120 nanometer. It is around 100 nanometer, the inner score, but with the spikes 20 nanometer. So it is altogether it is 120 nanometer. So then people are telling virus very difficult to cure, but bacteria, we have immediately antibacterial drugs. If some X is affected by a bacterial infection, if the doctors are identified what type of bacterial infection it is, this patient got affected, then immediately there are antibacterial drugs are available. Antibacterial drugs are available to cure. So in 3 days period, the efficiency of the cure rate is getting improving. So the bacteria are killed by the medicine. But come to the virus. Virus, since the virus diameter is very small, I already told the smaller dimension, more surface atoms are or more surface energy. So that is why the bacteria, it is a regular configurations are fixed. You can easily study the structure of the bacteria. So once you know the bacterial molecular architecture, then you can easily manufacture antibacterial drugs through pharma industry. But since here the viruses are smaller and its surface energies are changing with the host medium or where it is going to sit. So it is very difficult to configure the structure, full structure of the viruses. So that it means the energy at the surface of the viruses are high compared to the bacteria. So energies are very important. So what energy? It is a surface energy. So always the viruses carry energy. That energy is getting released when it is finding a host. So that is why the host medium is important. So where the viruses are sitting, there it is releasing its energy and it is coming to the minimum energy configuration. But bacteria is different. The bacteria never change its site configuration. Viruses can easily changeable depending upon the host medium and the environment. That is why pharma people could not able to find proper antiviral drugs for corona type virus. But doctors are suggesting to improve our immune system in order to get rid of this virus. Even somebody got affected by this type of viruses. So if our immune system is increasing and we are maintaining our immune system, these viruses stay few days because its lifetime is 5 to 6 days, 3 days maximum, then it is decay time 3 days. So then it will die, it will go. So that way we have to improve our immune system, not by killing the virus. So that is the reason the nanometer dimensions are highly effective and compared to bigger size object or conventional object which we are seeing. Another one example is the lungs, Lungs is used for breathing. So we are getting air from air with all configuration, pollutions and other things. Then when you are when the lungs has lot of tiny particles, so we are calling it the air sacs in lungs. So we can say that it is alveoli. So the biological name is alveoli. So the alveoli is like a grapes, small structures, but it is collected together as a bundle, chunks, small grapes. So if you assume that the alveoli is all in the carry in a single bag, there is no small structure. Then the efficiency of our conversion, air to oxygen conversion, because we need oxygen for purification of bloods and other things. So if the oxygen level you want to increase, then the alveoli should be effective. That is why the viruses usually affect the alveoli region and dysfunctioning the separation of the air into oxygen. That is why oxygen supply to the body is getting reduced if a person getting affected by or got affected by this corona type thing. So just these two slides I put to get an important about the material having large surface area. So the large surface area you can create with these small structures or create with porous medium or create with some roughnesses and all. So ultimately, as long as we are increasing our surface area, so the effectiveness is getting increased. So the what are the possible ways? So we learn from the nature is also very important. Okay, now come to the microscopy. So I am basically focusing atomic force microscope, but background about the other microscopes also available. So I already told the microscope we are using in order to get deeper information about the material which is not possible through our naked eye. So the naked eye normally zero point 0.1 to zero point 0.2 is our resolution, normal human eye. So it means any two objects having the dimensions 0.1, so our it can be easily separated because the focal length is easily deconvolute. Whereas sometimes the sizes becomes smaller or size some eyes which is little weaker. So we will see the objects instead of two objects, it will become a smeared one object. Then we need a glass in order to convert to the focal point. So for that we are using lenses. So the first magnifying devices to see an objects in the bigger way is lenses. Yeah. So that is why the light microscope, the lenses is used in the light microscope. Then another electron transmission electron microscope, the same period actually, okay, not very, but it is a sub of transmission microscope scanning electron microscope. Then 1980s scanning tunneling microscope. Then the same period scanning near field optical microscope. Same decade atomic force microscope, magnetic force microscope, lateral force microscope, these are the. So basically there are three lens based microscope, then electron beam energy based microscope, transmission electron or scanning electron microscope, then tunneling. Tunneling is one of the important thing we are not touching, but the tunneling concept is very important because the quantum mechanical tunneling, so it is basically the tunneling microscopes works based on the quantum mechanical. We are thinking that objects of smaller dimensions, for example, electron has dual character. It can behave as a wave as well as a particle. If you assume as a wave, then it will tunnel through the band. So if you assume as a particle, then it cannot be tunnel. It will bounce back like a normal object which is hitting on the wall. So that way the tunneling concept is important in the tunneling microscope. Then atomic force microscope is, okay, one by one I will discuss. Optical microscope, so basically any lenses. So any objects which is seen through our eye, so you will see a magnified image through our eyes, the convection. So when you are using a scanning electron microscope, The primary source is electron. So a bunch of electrons are bombarded with high energy, 5 to 30 kilovolt or even higher, 100 kilowatt. So that electron is focused through magnetic lenses. So basically electron, but we are focusing and putting an object, and underneath the object, so above the object, this electron beam scan an object. Then the detectors are detecting the information from the body. So when it is electron is interacting with the matter, second electrons are producing secondary electron, backscattered electron, OJ electron, X-rays are producing, fluorescent rays are producing. So basically each information is different, but depending upon the, suppose I want to collect the image, then people use a detector which is sensible to detect secondary electron or backscattered. Normally secondary electron. So backscattered electrons, if you want to highly resolved information, because we have to use energy larger, because the penetration power of the electron beam inside the solid is high. So this is the electron beam when it is hitting. So this is the way it is propagated. So very local secondary electron, then more spread backscatter, then X-rays are generating, because these backscattered electrons are hitting the material. X-rays are producing by deceleration of that electron. Then there is a continuous X-ray, characteristics X-ray, then fluorescence, light radiance. So these are the fundamental way scanning electron microscopes for. Well, people are converting this detector observed by the secondary electron information. So they are configuring the image. So this is the electron image, secondary electron image captured by a scanning electron microscope. So here the objects are very bottom. So it cannot be, the electron beam is not transmitted through the sample. It's inside, but any material you can put it, but it's just a surface exposure. Surface, the thickness of the region is 100 micrometer maximum. So if I want to put insects, biological thing, then I have to reduce the accelerating. If I use too much, then it will catch carbonate, or because of the high energy, so it will burn. So they are putting some coating also to get the insects. So then another one is transmission electron. Here the samples are here. So the similar way, scanning electron microscope. Here the transmission electron microscopes also working with the electron beam of high energy. Here comparatively high, because the beam can penetrate inside the sample. So the sample thickness is also the locally, the region where the electron beams are transmitting should be less than 100 nanometer. Otherwise, the information you cannot get in, because the transmission electron microscopy is one of the good example, good device to map out the electronic configuration, atomic arrangements in a material. So that is why it is very important. So then there is a intermediate step. All the information is falling on the fluorescence screen. So here also in between they are putting the beam lenses after the transmission. getting transmitted, then the transmitted beam is converted and deposited on the fluorescence. So the image of the material which is captured by the electron beam is recorded on the fluorescence. It's a way the transmission electron microscope is working. But we know that grains and grain boundaries are very common in material. So the grain regions are very perfectly arranged. The boundaries, because one grain, another grain, the orientations are not uniform. So it is some tilting arrangements are. So that is why we are calling it is a grain boundary materials are 2D defected material. It is not a perfect single crystal. Perfect single crystal means should not create any boundary. So the throughout the medium there should be a single polarization, single orientations of the atomic arrangement. Then we can say it is a good quality single crystal. But here, normally most of the material which we are seeing is polycrystal and consisting of grains and grain bound. So this is the one way. If I are taking a scanning electron microscope, if I take the materials of a grain with a grain boundary, the solid continuous regions are grain and the boundaries. So small boundaries are there. And also the way if you look more closely, the orientations of the atomic arrangements here is different from this grain, because depending upon the boundary energy, the orientation varies. So if I took the same type of material information from the using transmission electron microscope, you can see compared to the previous one, this is a little focused. So more information you can get it atomically. The boundaries. You see the line. Each line is arrangements of atoms. Arrangements of atoms. These are interatomic. Each separation is a separation between two atomic layers. If you look at the same material with a atomic force microscope, so you will see the quality still finer. You see separation between an atom. You can nicely see the atomic configuration in air. That is why AFM has advantages compared to other techniques. But it's difficult to get this type of information. So when you need a good quality material. How this atomic force microscope works? So this is a comparison. Traditional light microscope. So here the mechanism is light scattering and electron scattering. So the resolution micrometer to ounce, the lateral. This is traditional light or electron microscope. Compared to AFM, the quality is, the information is from the tip. Tip, I will tell you what is the tip. The interaction between tip and sample. Tip is also a solid. So we called it is a probe tip. But that is why they are putting tip. But usually the resolution you can see in nanometer, 2 amps. So and also the height information, height of the sample or height of the structure, you can easily trace from there. AFM cannot replace the electron microscope in general, but complementary each. AFM is not just a superior in high resolution imaging, but more importantly, can target and manipulate just one atom or molecule. You know, nowadays, I don't know your syllabus, single electron transistors, single electron switches is already emerging. Biocomputers, all technologies are different. In future, nowadays this digital, what we are seeing in the binary 0 1 0, it is no more. It can be decoded with a different way. That is why the bio or by brain capturing how the information from the brain. So there people are trying to manipulate brain into a computer and how the neural networks are converting that information and coding, decoding, all it is a different way. So if you want to go deeper, that is the thing. New technology or new emerging technology is a molecular type, molecular chip, molecular computer, or biochips, biocomputers. Because people addressing why these are important, because the biocomputers are operating very easily with low energy, and the efficiency of the biocomputing is very highly superior than the conventional. Conventional means mostly silicon based. All the devices are made by silicon or silicon based material, silicon nitride or gallium nitride, gallium arsenide or gallium phosphide or some materials are always good. But when they are coming to the molecular level, so if they are properly assembled, they are properly decorated the molecule in the functional way, then the efficiency of the capacitance or whatever the memory, when you are using the molecular, is very high and superior. That is why people are targeting. But this is a setup in our lab. We are using atomic force microscope. So atomic force microscope is atom probe microscope. So it is a microscope means you know that microscope is the device seeing an object which is not visible, not seen by our visible eye. So it means smaller object can be easily seen by magnet. How then? I already told optical microscope. We are using the magnifying an object through lenses. Then we are viewing. The electron microscope and scanning electron microscope, we are using electron beam. And the electron beam either transmitted or scanned at the surface. If it is scanning at the surface, then we call it is a scanning electron microscope. If it is transmitted and get the information from the atomic arrangement, then we are calling it is a transmission electron. But here, atomic force, the word, there is nothing in between, electron or light. Here it is a force. How a force is converting into an object? That is a question. That is the important about that technique. So basically, the technique consists of a AFM frame at the bottom. It is a vibration-free platform. It is sitting. Then there is a scanning region, X-ray scanner. So it can be move X-ray rastering the surface. So this is the sample assembly. This is the region. So here head. So the head has the capacity. It can be moved here, here, depending upon the force. I'll tell you what force it is acting. Then there is a movement. This CCD camera is sitting at the top. It is focusing the information. Okay, importance of AFM. AFM is a high resolution type of scanning probe microscopy that allows us to see and measure the surface structure in length scale 10 nanometer to 100 micrometer with unprecedented resolution and accuracy. Lateral resolution 30 nanometer, vertical resolution 0.1 nanometer. Vertical resolution is very. Unlike an imaging traditional microscope, AFM provides height information. That is why the resolution is very good. Height information of the sun. Other technique is very difficult. Other microscopic techniques. Almost any sample can be imaged, be it very hard or it is soft or individual molecules or whatever. We can generate images which look at the sample from any conceivable angle with a simple analysis of it. Currently, AFM is the most common form of scanning electron scanning probe microscope and is used in the field of science, biology, physics, material science, nanotechnology, astronomy, medicine. Actually, how it works is this curve is very important. I think you people are very familiar this LJ potential. Right. So any two objects basically. So the any two objects are well separated. For example, here any two objects is well separated. But here, basically, I'm telling before that, this is the tip. What we are telling is the tip of the cantilever probe. So the tube theoretically consists of only one atom. So they are tapering in such a way that the sharpness of the tube consumes one atom at the tip. Assume that this is a sample. The blue color is a sample. So when the tip is rastering, so it will moving from one edge to another edge, but it is not damaging the tip. But you know that the force is acting at the region where it is very perfect. Then that force it will maintain. So when it comes to closer to this domain region or some dome, then the tip or the instrument know that okay, some thing is there, some interference is there, so it will adjust the tip height. The assembly has a piece of material, so it will adjust the position in such a way that it maintain in the tip, maintaining the constant force. So it will maintain always the constant force. So the constant force wherever varying, so it will change the structure. Okay, this is the thing it is important. Force distance curve. Any two objects, assume that the tip and sample. So two objects in our case, sample is one object, the tip is one object. If the sample and the tips are well separated, the interaction between the tip and sample is negligible. So that means the energy or force which is acting is very low. That is why its x-axis very long. But now I keep the tip sample and bringing the tip together closer, bringing the tip closer. For example, I am using this bed in such a way that there is a tip is here that I am bringing down to closer to the surface. When I am bringing closer to the surface of the sample, test sample, the interaction, so the probe see the interaction. the probe see the interaction. So it means when it is very far away, probe and sample no interaction, so it is does not know what it is. But when they are close, coming closer and closer, so often very close to the surface, so then the tip know that there is some intervention in there. That is called, it is a attractive interaction. That region is called attractive interaction. Attractive interaction means there is a, when any object coming closer, so initially there is an attraction. But when it reaches an equilibrium, so the minimum energy. So equilibrium means any system has minimum energy. A person is sitting idle with minimum energy. But if a person is sitting with the energy when it is not in the minimum energy, either it is in the attractive region or in the repulsive. Your body functions like that, molecule. So any two objects coming closer, then initially there is a attraction. So LJ potential, also termed as LJ potential or 612 potential, approximate the interaction between a pair of neutral atoms or molecules. This is the general theory. Any atom, any two atoms coming closer, then the atoms are interacting. So in our case, two objects is one is at the tip, one is at the sample. So when the tip come closer to the surface, then there is an attraction. So then attraction is negative energy. So when come to the equilibrium, at equilibrium, the energies are very minimum, then there is no more interaction, then it will start to repel. So initially zero, attraction, equilibrium, then it started to repel. So when it is repelling, that is a repulsive interaction. Here it is attractive interaction, here it is repulsive. So when it is reaching the equilibrium region, so equilibrium region is the minimum energy configuration. So when any system come into the equilibrium region, then it will start to repel, repulse. So the force of attraction, force of repulsion. So these two things. So the force of attraction and force of repulsion is called 612 potential, or they are putting the expression r power 12 minus r power 6. So B and the A's are constant. R is the separation distance. So 12, one is r power 6. So this is the negative. This is attraction, this is the repulsion. So the repulsive terms is very fast. When it is under equilibrium, so it is started to repel very fast. But when it is very far away, when come closer, then the attraction is not very high, but it is slow process. That is why it is R power 6 times. So recording photo detector signal as a function. Okay. So this is the force distance curve based on the tip sample interaction. People are capturing the information. People are capturing the information, measuring the force. So initially allow the tip to come closer, and when they started to raster the material, scan the material. So basically this is the another way assembly. This is the cantilever we call. At the one side of the cantilever there is a tip, and the tip edge is very sharp in such a way that one atom is visible, not visible, one atom is sitting at the tip. Now we are moving the cantilever down, then there is an interaction between the tip and the sample. So here is atomistically atoms in the tip and the sample. So now when I am coming closer, At equilibrium season, you see this tip atom can easily see an atom at the surface sample test tube. So it means that is why it is called atom probe. So you can see or we can map out the information atom by atom. So what it is making is this cantilever moves this direction, this direction, this direction. X, Y, Z. Both X, Y, Z. So initially they are adjusting the position in such a way that there is an interaction force it is recorded, measuring. So it means the instrument can measure the forces between the two objects when the tip is coming closer. They fix the height in such a way that then they scan the tip or scan the region 100 micrometer by 100 micrometer. So then the tube moves 100 micrometer this direction, 100 micrometer this. So you will get the full information, atomic arrangement about 100 by 100 micrometer using this. If the sample containing some dust or defective, because the force initially which we fix is varying. That variation of the force, it will measure as a negative or positive force. Then it will give the feedback circuit. It will gain. So it means the structure has changed. Whether it is removal of the electron atoms or additional of atoms or impurity atom is there. So all the information, the force varies. For that, the reference state they fix at the beginning where everything is fine. Then based on that force, because that force we cannot manually doable, so all by computer iteration. So it will adjust the position, then it is we give the instruction to scan, so it will scan the information, and wherever the changes are there from the minimum, then it will record at the information whether the structure is doming type or some cavity type. How it is recording means the bending, the tip, no, the tip moving is like a cantilever, elastic cantilever. So the force is measuring, interacting. So when the object is coming closer, then there is a force. That force, due to that force, the cantilever started to bend. So then there is a light arrangement, laser beam falling at the other surface, other side of the surface. So here it is very highly transparent. So this light fall, suppose the tip moves down, so then the light reflection is different. So the laser beam here, yeah, laser beam is coming here, falling here, then it is detector, position sensitive detector is identifying the emitted beam, reflected beam. The reflected beam, if there is no change, the width of the reflected beam domain is very narrow. If there is up and down, then the region is changing. That is why it will record differently when it is moving from good region to other region. So in basically measuring the surface features of dimensions between 10 nanometer and 100 nanometer, 100 micrometer. It provides valuable information about three-dimensional topography as well as physical properties of the sample set. Topography, three-dimensional, because the height is here, it is very important. Other techniques measure the height, but it is not the true height. So only AFM can measure the true height. But the thing is, the resolution should be 100 below 100 nanometer. This is again the schematic view. But there are different modes. The tip, no. So the bottom, these are the sample. So when it is a non-contact mode, it vibrates on its resonance frequency. I already told in the last class, oscillating frequency of the quartz. So similarly, so each material have its own resonance frequency. So it vibrates on its own resonance frequency. So the choice of the tip and material you have to do depending on. Suppose if I am using very hard tip, hard sample, so I have to use not hard sample, hard tip. So I have to change it to sample. Otherwise, tip will be done. So choice of the tips is also very important. So basically, it will give the information about what I told. You have a two objects, so the tip moves, goes, and get the information about the structure. So if the tip is not very sharp, so the information is a little wider. But here it is perfect. Flat surface, flat region also you can see. But here not. So that is the thing. The quality of the tip is also measured, important, because when the tip quality is not good, so instead of one atom, few atom can be there, assumed. So the few atoms are there, then the resolution of the information is not that much good as compared to the single atom. So this is the actually already told, no, this is the experimental view. So this is a tip, the laser beam is focused here, so it will moving. So we are assuming this is the region we want to scan. So it is measuring. These are all auto control. So it is actually basically it is rastering. One side going, yeah, start from here, going, coming, then one step going, rastering in the reverse direction, come back like that. It is a rastering. So depending upon the size and the information which you are recording, so you have to give the information. Give the information and get the additional. So if I have a structure like that, for example, it is a mesh-like structure. So some conducting domain, some people grow on, and there is a free region. Now I scan the region. When I scan the region, I can see, you see the height. This is the height of the, from the bottom to this way. How quality about the image. All it can be recorded. They separate the width of the structure. And if I have another structure with a small structure with a separation, this separation is measured this. And the structures, these oscillations are related to this structure. If you want more, then you have to be zoom this region, then you have to be straight. Similarly, other side, other side. So these are the way the AFM technique is using. So AFM technique is nothing but it is an atomic force microscope. It measures the force and fix the force in a constant region, and that is considered as a reference, and it is started to ration around that region and map out the atomic configuration around that. So if there is a missing of an atom, one cavity, then the tip know that there is some missing of it. So for the force, because force, the scanning force is fixed. So it means when there is a more deeper, if you want the deep ones, then I have to give more force. So the positive force I have to give. So how much positive force I am giving, that is corresponding to the height of the structure. Now If assume that there is a impurity whose atomic dimensions are higher than the perfect, then the instrument know that okay, we need not give more energy, so we have to be relaxed. So it means repulsive. So it will start to repel. So one is attractive force, another one is repulsive. So the basically these two works and gain the information about the atomic image about a metal. So the quality of the surface is very important. That is why, but advantages are very high. Advantages is comes in minimum sample preparation. So then it does not require a conducting sample like scanning electron microscope. So provide a three-dimensional surface profile. Works perfectly well in ambient air because here the environment is not an important. Only thing is we have to provide ambient air with vibration free. Vibration free is very, very, very important because it is measuring the force and the force is centinewton or millinewton force. With the vibration, for example, if the working is not in the closed area, then even in the light signals or in the vibration from the wall or even when we speak, all vibration can be disturbed. So that is why the measurement environment is very, very possible to study microscopic and because normally when we put it in the biological sample in the scanning electron microscopy, electron beam is interacting, so it will burn the surface. But here that is not possible and that is not happening here also because here only we are measuring the force in the non-contact mode interaction. So that's all. So in that way advantages are there. But in other way disadvantages also there. Not practical to make measurement on areas greater than 100 microns. Limited scanning period. Where it is recorded, the information is very, it required long time. Several minutes to several seconds. Yeah, several minutes, several seconds to several. Images can be affected by non-linearity, hysteresis. Quality of the sample, if it is plain or well and good, otherwise it is a problem.